13 years now. For 7 or 8 of those, I was the architect for web interface. Web interface started, getting everything out of order. Sorry, let me start with this one. The purpose of this session really is to don't panic. This is a survival guide for understanding identity and access management. This is a subject you guys probably don't very often need to know much about, but I'm going to argue that it's going to impinge on you sooner or later, and this is sort of the basics of what you need to know how to have those conversations when they come up. And the reason why I'm going to talk about that, and why I'm probably a reasonable person to do that, I've been the architect for web interface at Citrix for years and years, and that started in the Windows application desktop delivery space, of course. Over those years, we did things like portal integrations. In 2005, we did an integration with Microsoft Active Directory Federation Services, which is their identity federation product. And that brought me into contact with lots of customers doing interesting and unusual use cases. And actually, that's sort of been my experience with web interface all along. As the architect, I only really get involved if they're sort of unusual, sort of long tail use cases, if you will. So over the period of years, I've started to find myself getting more and more connected to this identity and access management world as people in that little intersection point end up coming to me to help figure out what we're going to do. But interestingly enough, I've seen, particularly over the last year, it's been really noticeable. I've had more and more conversations with customers relating to identity federation and topics like that. A surprising uptick in that, which I think is going to continue. And of course, we've had lots of new areas emerging again in the last year or two, which relate closely, touch on identity access management, everything to do with using SaaS services, people using mobile applications, which may need to call SaaS services or call the enterprise, needing to use cloud storage even. And we're at the stage now where people are actually thinking about and looking at how can we have things like a Windows desktop loading its profile, saving its profile into cloud storage, just so those documents and things are visible automatically to other devices that you use. And kind of in all these areas, dealing with identity, dealing with authentication is sort of a significant part of the design challenge, and that's what I've ended up gravitating towards working on. So this is kind of a preview of a quiz I'm going to come back to later in the session, but it's like a good checkpoint to see what level of understanding you've got. If you'll eventually, by the end of the session, hopefully have a good idea of why, what's different about authenticating to a web application or website by using a password or by using Kerberos or a SAML token. And, sort of getting you that level of understanding is probably a good way of having a handle on the identity access management issues that at some point will affect Windows. So we'll come back to that. But for now, let's just talk about the scope of identity and access management. So this is my understanding of the scope. People think of it, of course, as starting with authentication and verifying the user identity. User presents credentials, and you verify the identity. You can do that by direct authentication. That can be username, password, RSA token, smart card, client certificate, biometrics, whatever. The other way that I'm seeing more and more interest in is federation, and that's where you've authenticated to some other system than the one you're trying to access, and your identity has been proven by if like a third party, and on the basis of that, you're being allowed into this system. That's what I call the inbound mode of federation. Then there's obviously a significant use of identity once you've got into a system for access checks, authorization decisions more generally, and in some cases, when the system is composed of multiple parts, your identity has to flow through those parts by some sort of delegation mechanism. And then there's a possibility that you then have to translate the identity at some point in that step, at some system boundary. For instance, you may have logged into a Windows desktop, but then an application is using a different identity. You want single sign-on, so you have to do a translation. In some cases, people will do this literally with password manager style products where some system has your credentials. It's unlocked based on that first authentication, but then the credentials for an app are sort of being fed into it, and that's identity translation. But the more modern way of doing this is, again, federation. This is now the outbound case. If you've been authenticated directly at this system, then carrying your identity to some other system which is prepared to trust your authentication. That's that outbound federation step, which sort of takes you to another system, which is, if you like, starting at the middle of this diagram again. So all that's just the runtime handling of identity that you'd expect. Of course, the access management side of things is also concerned with the whole life cycle of user identities. And that's going to start when somebody, a physical person walks into the door, if you like, they're hired for a job, and you need to prove and work out who they are as an individual, at least to whatever level you need to know and understand them in your system. So, verifying, physical addresses and bank accounts, and checking criminal records and all that kind of stuff. That's sort of identity proofing. And if you've satisfied somebody's, who they are for your purposes, you can give them an account in your system, issue credentials for that, whether it's password or something else. And then you're into the management of their access rights, what they can do inside your world until the day eventually comes when, they shouldn't be there anymore and you deprovision everything. And of course, you've got the concerns along the entire stretch of how to administer all of this infrastructure, how to audit what's happening, both at the administration layer and at the runtime layer. So that's kind of the big view of identity and access management. I'm not going to talk sort of about all of those things. You'll be pleased to know, but just so you have in mind, that's the scope we're thinking of. So hopefully, probably the question on your mind is, if you're involved, as most folks at BriForum, I guess, are, with delivering applications, Windows desktops to users, you're probably thinking, what does identity access management really have to do with me? Do I need to understand it? Do I even need to care about it? And probably up until recently, you may well the answer to the bit, no, I don't really need to know or care. Actually, just out of interest, how many people have had experience with using systems that do, say, SAML authentication or OAuth, Kerberos constrained delegation? Yep. How many of you have ever had to try and debug problems with Kerberos? Have you used Wireshark and understand the ins and outs of its tracing? Okay, a few at least. Some of those kinds of things you may find yourself needing to deal with a little bit more in the future. And actually, sort of this presentation, the first part of it is me trying to make that case as to why I think you will ultimately find yourself needing to care, or at least needing to understand something about it so you can have those conversations when they come up. So the way I think of the case is a bit like this. Let's suppose for the moment that most of the world is a straightforward Windows domain-based environment, Windows desktops, and you've got ordinary applications running in your environment, things like the Office applications, they're using file servers maybe you have things like Outlook connect to Exchange, but that's all sort of Windows integrated authentication. Log into this system is straightforward. It's 80 passwords normally, and if somebody's external, maybe they also log in with like a secure ID, something like that. And the use cases, again, straightforward, simple ones, primarily employees, mainly working from the office, sometimes connecting remotely. Maybe some people like contractors, but you deal with them as if they're sort of employees. They're just given accounts and ID and allowed to access the systems, and you just use ordinary Windows access controls for restricting things. So let's say this is most of the world for you folks most of the time. If this is your entire world, really there's no identity access management problems that you guys face. The security team may have a different view. But my experience is there's something outside of here which probably applies to you, whether it's more complex applications or different authentication needs, more complex use cases. And the pattern I've seen time and time again is these exceptions have a way of infiltrating all of the assumptions in this architecture and kind of breaking things apart. And in extreme cases, they can almost cause much of the architecture to be flipped on its head and rethought the way it has to work. I've seen that happen, and that's partly why I've have this talk. But really, my view is even if most of your world is the simple case, it only takes one or two exceptions to really cause a real problem. So let's look at those categories of reasons again. We've got applications, authentication, and use cases. So the first category of applications I talked about, these are the straightforward ones. They're applications that just deal with files, let's say, either locally in your profile or maybe on file servers. But for them, identity is almost nothing more than the Windows profile. Excel and Word, you don't have login as such. It's just the profile. Applications like Outlook, of course, they connect to Exchange, and they'll normally be using pass-through authentication, but they're AD authentication based. And there's various other applications people might write in, say, .NET client-server apps that'll follow this pattern as well. And your web applications like SharePoint, which is a very good example, again, pass-through Windows authentication is the default for SharePoint. And it's a straightforward world. The worst case, maybe you have to deal with some sort of multi-tier delegation issues with SharePoint at most, but it's nice and straightforward. But I bet there's probably hardly an organization in the country which is simply in that world. There's usually at least one app, maybe more than one app, that's in this next category. These are the line of business applications, whether it's financial systems, reporting systems, planning systems, engineering and manufacturing. And the characteristic of all of these systems, this is the SAPs of the world and the Perforce, if in our case we're a software company. They all have their own individual accounts. And now, from your point of view, it's not your problem. It's somebody else's problem. They can run the app on the desktop, or they can run the browser to connect to the web app. Yes, the users have to deal with these passwords. It's a pain, but it's not your pain. But it certainly causes a lot of security problems. And the same pattern applies to almost all SaaS things at the moment. Citrix is probably not unusual. We have outsourced HR apps. We have an outsourced travel system for booking flights and things like that. And I've got a username and password in those things. It's the same story again. And if you're the person thinking about identity and access management, you're even more worried about this because it's not only an extra account, it's out of your control. It's held in somebody else's systems. And then if you think about all the mobile applications you get on iPads and things like that, the model for them, a few of them just run locally, perhaps games and stuff, but most apps of interest connect to something, some cloud service or maybe to email. And again, their identity model for that is explicit authentication. If it's the email app, I've got unfortunately my corporate username and password stored on my iPad to connect. If it's Dropbox or Quick Office, it's connected to something like that. It's the username and password for that cloud service. Again, not a good position to be in, especially with these passwords now stuck out, cached persistently more or less on these devices. That's a concern. So obviously those problems have been driving people in the identity access management world to think of solutions. And by the way, the t-shirt I've got on is from a conference I went to last week in Colorado, which is all about identity and dealing with those kinds of issues and how to solve the password problem and how to get rid of passwords forever, how to deal with legacy systems that are based on those things and bring them into a new world. So that new world actually kind of exists already. There are in some cases new line of business applications that have been written the modern way. I'll talk about this a little bit more later. But Microsoft has been banging the drum on this for quite a few years now as of a better way of doing it. And certainly there's a new generation of SaaS web applications, Salesforce, Google Apps, and actually Office 365 is a very interesting one. They are now based on this federation model. You don't necessarily use a username and password that's specific to Office 365 to log in. They know how to federate back to an enterprise. Salesforce does that, Google Apps can do that, and more apps are going to go this way. It takes time for, when people start a new SaaS company, they're not thinking about how to do identity. It's, they're worried about just getting a product that works and does something useful. They'll deal with identity later. If they're successful and enterprises want to use it, then they want to say, how are you going to let me log in? I don't want to have yet more accounts with you. So people are learning to do federation for this. And even some mobile apps are finally catching up. I noticed that, I suspect the Office apps, for instance, will know how to federate to the enterprise to get to Office 365. But Salesforce has now got an iPad app which knows how to do SAML authentication. So that is just starting to happen. But even apart from the enterprise federation, some of the new mobile apps, when they're using cloud services behind, they've also moved to a federated sort of technique for doing that authentication, which I'll go into a lot more detail. So sort of my contention is these blue roles, this is where the world is moving. And as it gets there, that is going to make people stop and think about whether the top row of Windows-based identity can be left alone or not, which is where things get quite interesting. And, so actually let's follow that line of thought a little bit more, because I'm saying, I think the trend is for all applications eventually to move to this federated identity model. And here's why. Suppose you're an application developer in-house. So you've got tons of existing apps to maintain, almost certainly, and chances are you've written a lot of them on the Windows platform. Microsoft has a very good following of in-house application developers. You might have used .NET, or you might have used any of the other 6 technologies Microsoft has pushed as the thing to use over the last 15, 20 years. So you might even be using all of them. You could, of course, be a shop that's using another alternative platform. I've seen plenty of customers who have big WebSphere or WebLogic or Tomcat-based applications that they maintain. And there's probably lots of companies who can count an Excel spreadsheet somewhere in there as an application as well. But the point of all these things is the advice, and the advice has been probably this way for a few years now. If you're an in-house developer and you have a chance to write a new application, why would you not make it web-based? And these days, web-based means HTML5. Why would you not do it that way? You'd have to argue, if you needed to do it a different way, why that was the case. So that's rule number one. And the corollary is, if you have all these other existing applications, when you have the chance, you should be thinking about whether you have any way of web-enabling those in some way or another, whether you rewrite them to be web-based, like the first style, or find some way to convert them, make them more web-friendly. This is what folks have been trying to do for the last several years. In fact, now the game, of course, has moved on, because the modern in-house app developer should be thinking about mobile applications and how to make things that make good use of iPads that are touch sensitive, use the form factor properly, are just nicer to use. The bar is constantly going up. And when they're thinking of trying to do this, especially with their legacy systems, the only way they're going to web enable these things or mobile enable them is really to put APIs on them to make them service oriented. And it's not a trendy buzzword anymore. It's been around 10 years or more, service oriented architecture, but it is actually the right approach for doing this stuff. And these guys are beginning to realize that. And it's not just them. Basically, if you're an ISV as well, almost if you're anybody developing software, basically the advice now is think like a SaaS vendor. Either try to become a SaaS vendor yourself, or think like one if you don't have that opportunity, because you are basically going to compete sooner or later against a SaaS vendor who's building from scratch the modern way. So for a SaaS vendor, again, the story looks very similar. Every SaaS application is almost automatically a website, at least a web application, and normally it's de facto to have a mobile application. If you don't have it at the very beginning, you should be developing one straight away. And all of these guys, Salesforce, Google, Microsoft with Office 365, lots of other folks, they're starting from API basis. In fact, the conference I was at last week, one of its themes was what they call the API economy. And it's this observation that more and more products you may not sell a product, you may actually sell the APIs and access to the APIs and charge people to call the APIs and use them. And this is the way the SaaS vendors are thinking now. So it's the way really everybody needs to think. And it leads them very naturally to an authentication model that works well for APIs and that can scale. And that model follows what I call the federation pattern or token-based authentication. And actually, it's not just authentication, it can do authorization as well. And that's sort of a standard pattern that's emerging. And this is just a list of some of the folks here at this conference I was at last week who are basically all in agreement with this model. Big name companies, both enterprise and SaaS, various industry analysts and vendors developing products to help. Because there's vendors in there who are developing products to help folks with in-house legacy systems that may be Java-based or Corba or COM or whatever it is, mainframes even, help them make RESTful web service API points layered over top. That's a new market that's emerging rather rapidly. Okay, so hopefully you can see that the application trends are, at whatever speed people can manage moving towards this federation model. It's going to take lots of folks a long time to get there, but it's happening. But that's not the only driver. We talked about the straightforward authentication methods that are straightforward and aren't a problem to deal with. at least from your point of view, it's straightforward to give access based on 80 passwords and one-time passwords on top. But if you're the identity access management guy, you're looking at this right-hand column and thinking, passwords are killing us. These things are not secure. They're not friendly for people when they have to remember lots of them and they have to change them so often, remember longer and longer passwords. The one-time password tokens, yeah, much more secure, but now it's a cost. They're physical devices. People can lose them. They may have to charge for every individual physical device. The user experience can still be a bit clumsy in some ways. Soft tokens, slightly better from the user experience, slightly worse on the security model. But the problems with those things are gradually driving people more and more to this sort of new generation or this sort of next level of authentication technologies. It's going to happen slowly, of course. Passwords have been around for a long time, and they will be around for a long time yet. But there are organizations already moving to smart cards, like 100%. Organizations which users do not have a password, or more accurately, they do not know their AD password. It's completely random and unknown to them. They have to use a smart card or maybe a one-time password to log in, nothing else. Or they're using digital certificates. There's people more and more interested in biometrics now. And the challenge with all of these things, and this is, so I've been facing this over the last few years in my job, is how do we support those set of methods when you're trying to access Windows applications and desktops? It's not so much of a problem for accessing web applications, for instance, but it is more of a problem trying to do a Windows application, which I'll come to a little bit later. And then for use cases, so it's not necessarily true, but let's suppose that dealing with employees is the straightforward use case that's not really problematic. But then, after 5 minutes, I sort of came up with a long list, and I'm sure there's dozens more that could go on this list of other use cases, which, any one of which can be one of those troublesome use cases I talked about. You've got, say, supply chains. You've got external people. You need to give them access to some of your systems. You don't want to have to create accounts for them and deal with all the headache and the cost of them telling the list of users and you agreeing the passwords and you paying if they have to reset them and so on and so forth. So people have moved for the model of doing federation, true federation for supply chains, and businesses now are doing things like spinning out part of their operations as to separate companies, and suddenly that becomes a federation model. There's interesting industries where you have joint collaborations. Oil and gas is a good example where it's so expensive to do drilling and geophysical surveys that companies will pool their resources to fund it. But they're competitors at the end of the day. They are very conscious of the IP that's being generated and created and who can access what, and very, very concerned about the security model, all of that. So that leads to lots of complexity for setting it up, of course. But so I suppose the bottom set of models here are ones that tend to lend themselves to a federation approach, either because it is necessarily a federation scenario, or the approach of federation helps in some way with achieving what they want to achieve. So I had thought of lots of more models of some specific examples I've come across in the last few years, but I thought I actually don't have time to talk through them all now. So they're attached to the end of the slides. If you ever get hold of them and want to look at that, you can look through them. But let's spend a moment now talking about these federation techniques and token-based authentication that I've been talking about. So I think it may help you to have a framework for authentication. This is something I've learned. I've seen people struggle with understanding how authentication works. And it's something I figured out for myself as a way of understanding. So let me show you the model I've got. You have a user who wants to access a system, and you have a system, and I'll call it an identity provider, which knows about them. Obviously you have a password knowledge in both places. Let's say a password or some credential so you can authenticate. You've got another system called a service provider, which has some sort of resource that Joe may need to access. And in the most general model, you can have a trust relationship. So the service provider can trust the identity provider to confirm who Joe is, so you can give him access. So service provider is going to know about Joe, that this principal that he wants to allow access, and what level of access, read, write, let's say. And then there has to be some sort of runtime operations where Joe can authenticate to the identity provider, and then carry that identity to the service provider. So that's the conceptual model we've got. Of course, sometimes identity provider, service provider are one in the same system, and it kind of collapses down to the direct authentication model that is that problem case we talked about. So many systems have their own private accounts, and you basically present your credentials as you try to access. But that is just not a scalable approach. It's on its way out. People can't cope with remembering lots of different passwords. So really, the federation model is the only one that's got legs long term that we have to move towards. So the model is, in exchange for the authenticating the identity provider, you get back some sort of token, this sort of my representation blob here, that you can present to the service provider that he can in some way validate and infer the identity from that. And that's the fundamental model of federation. Now, there's actually some quite interesting possibilities that come from the federation model, which may not be immediately obvious. So if you start with the situation of the identity provider just knows who Joe is and can approve his identity, but the service provider is the one who has the access control policies, the read-write bits. It doesn't have to be that way. You can actually say that read-write logic, the entitlement of Joe to do that operation could actually move up to the identity provider. That access token could equally well convey that information as well as his identity, and it's all trusted. In fact, you can go a stage further and say, let's introduce a step in between. What if we didn't want the identity provider to know all the access rights? Because maybe we have several identity providers for different users. Maybe the identity provider is actually in a different organization, some of those federation use cases. So that my supplier confirms somebody is one of their employees, but I may want to control the access rights. So I may want an authorization step in here. So I move that down to another component on the chain. And this works straightforward. You get the identity token from the first guy, and you give it to the authorization step. And then he generates another token of his own, which can add on the information about the access control that he's allowed to have, the entitlements. And you can go a little bit step further, and you could generalize that middle step to say, not only can I sort of add information to what the identity provider asserted, I can change it. So I could, for instance, say, I'm not interested in necessarily knowing, is this Joe coming in? Because maybe Joe's in some external organization, and I don't care which of the 10,000 employees in McDonald's is trying to access my system. I just want to know if they're entitled to use a particular system. So maybe as they come in, there's some system that can take their identity and assert, actually do what we call a claims transform and say, actually, Joe, treat him as being a clerk. He's entitled to do those sorts of operations. Maybe the rewrite information stays in the middle, maybe it goes down to the bottom. Either is possible. But this is the model that Microsoft has been developing and now articulating at their developer conferences for several years now, what they call claims-based architecture. And this is the model that SaaS folks are going for, that people developing APIs are going for. It's just not scalable, just like it's not scalable to have every system have its own set of credentials. At some point, it's not scalable to have every system have its own individual access control rights, because now, if you're trying to audit something and understand who can do what, you've got to crawl across so many different places to figure that out. It's just not manageable. So having this separation is very powerful, and that's where it's moving, and it's enabled by this token-based model. So let me talk a bit about some of the claims-based protocols that actually exist in practice. And they basically all follow that pattern in one way or another, in some variation. I had a look, and I was thinking at one point I might have to draw a diagram that's a bit like the history of Unix systems and how they evolved and split and recombined. But it actually turns out not to be necessary to do that. Really, there's only two protocols that matter in this space anymore. Basically, SAML and OAuth. Now, SAML is the older of the two. It's been around, I think, just over 10, 11 years now. And OAuth is kind of the new upstart that's been created quite recently. It was actually started by folks like Facebook and Twitter for solving their problems. They wanted to allow lots of people writing third-party applications to connect to their systems, and they didn't, they wanted to get away from passwords. They wanted to solve the password anti-pattern, as they call it. So OAuth was developed, and it's interesting, they decided not to use SAML for doing that. And I'll come to the reason why in a second. But in terms of where they are today, they're both full federation protocols. They can both be used for solving the same kinds of problems, but they've ended up with their dominant use cases. So SAML today is mostly web single sign-on. That can be business-to-business federation use cases. It can be, like if you log in actually to Google Apps, Google themselves, just for their own internal systems, is giving you a SAML token as you come to the outside that lets you into internal things behind the scenes. Whereas OAuth is focused, built, grown up more around APIs, like I say, Twitter and Facebook, letting people access their data through their APIs from third-party applications. But they can both sort of cross-serve each other's use cases in some way. But really what's driven them is SAML, some of the technology implementation choices. So SAML ended up being based on XML. XML was sort of the new hot thing 10, 11 years ago. So they went for the model where you cram a lot of information into an XML document that says who somebody is and what you know about them in a lot of detail and sort of like schema level information so you can understand exactly what's being said. So they got to be large XML payloads, and then you have to digitally sign them, and that turns out to be actually really quite expensive for XML in particular. But it's mature. There's lots of security options for doing this. But it sort of stopped evolving, and really people are now, in reaction to how heavyweight that was, folks like Twitter and Facebook decided they were not interested in doing really heavyweight processing. They wanted something that was just simple, just enough to do the job. So they went for things like JSON encoding of just the little bits of information you want, and very simple tokens they're usually just a random number that you kind of confirm with the issuing party, which makes them very cheap to validate. So not many security options yet, but they really are developing rapidly. OAuth is actually in the process of becoming an IETF standard, so that's one of the internet standards. And it's for APIs. People have already rapidly started using it just because it's the only sort of decent standard out there that's not username and password. So here's what the process looks like. I'll sort of talk through from the next level of how the auth flow works, just so you get an idea for that. This is the SAML one where it's the traditional SAML one where you use a browser to access something. So the identity provider here could be could be, let's say, a corporation, and the resource provider at the bottom could be something like, say, Salesforce. So the model might be that the user tries to go to the Salesforce page, and they're not logged in. Salesforce doesn't know who they are, so it needs to redirect them to get logged in. Now there's a bit of magic for it to know that it should redirect them to that particular identity provider. That problem is called home realm discovery. I'm not going to talk about how it's solved, but let's assume the browser gets redirected there. So the user goes through the normal sort of login process with the identity provider, and what is generated is a SAML token you carry to the to Salesforce, and that token has got, like I say, it's XML. It's chock full of lots of information about precisely when it was issued, how long it's good for, which server it's actually intended for. The ability to say this token is only meant to be used by Salesforce. If Salesforce gets it, they can't use it to talk to Google Apps or anything else. And buried inside somewhere is the actual username, with about like 100 times as much XML around it, because you've got all the namespace declarations, and at the bottom you'll be a digital signature that was calculated in the whole thing. That's usually enormous in its own right. But kind of in a nutshell, that sort of 100-to-1 ratio, which is pretty accurate, is why OAuth was created. That was just too heavyweight. But one of the other models, and by SAML here I'm counting all the SAML-like protocols. So SAML is capable of being used for things like rich clients. So I've used OneNote here as an example. I don't know if they've actually done this yet, but let's assume OneNote can do enterprise federation to Office 365 cloud services, which I suspect they can. The way that might work is Office 365 might be the bottom thing on the right, and this chain allows for this full sort of claims transformation. So Fred, his app, knows to try to talk to Office 365. He gets told he needs to authenticate, and he needs to get a token from this intermediate party, which is going to do claims transformation, authorization of some form. But he's going to say, I don't do the identity. You need to go up to your your corporate, your enterprise identity provider, say an ADFS system. And you can authenticate to that by whatever means the enterprise wants, and you get back the same sort of SAML token we saw before. And then that SAML token can be passed to the middle tier, and he comes back with the real token that you present to, say, Office 365, which perhaps instead of Clark, it might be asserting which company you're part of or something like that. But so it'll just have something instead of the username, it might have something inside that says a different attribute of a specified type that I'm going to assert instead. So it's a very rich and powerful model, but again, very heavyweight. So the OAuth model, and this is the sort of the commonplace one that's, say, used by Twitter or Facebook or folks like that. It's actually more of an authorization model. That's how it was originally created. The model was to be able to say, I want to authorize this application to call my services. So I used OneNote again, not probably just a fictitious example, but let's say OneNote was trying to call some service, whether it's an enterprise service or a cloud one, let's say Acme runs. Their model is they need to be authenticated, but actually the bottom party says you need a token to call me, and you can get tokens from this other guy up top, but because it's an authorization step, you usually need user consent to agree to it. So actually the flow jumps from the application normally into a browser at this point. So the browser now goes to the identity provider, he goes through the login sequence, and then you get this step which you may have seen if you've used things like TweetDeck, let's say, and authorized it to use your Twitter account. The party that owns the identity, let's say your corporation, is going to talk about this application that's trying to access something and whether you want to agree to let that happen. So it'll talk about the consequences of what's going to happen, and the user agrees to this happening or not. So if they agree to it, what comes back actually, and the browser passes this back to the application in some way. In worst case, Joe actually has to take the code in the browser page and type it manually into the application. But usually there's an automated way. He gets back a temporary one-time code, and then the application can validate that code with the identity provider, and what he gets back is actually some of the real tokens he's going to use for calling things. And in general case, he might actually get back 2 tokens, one to use immediately, but another one that he can hang on to for a while. This is a refresh token, and this is sort of why this whole process was done. Instead of all these applications saving your username and password on an iPad, where somebody can eventually crack it open if they steal your device, you basically replace it with a refresh token, which at least is only good for this one thing and only good until it expires. But then you have an ordinary access token, which you can then send to the resource provider. And quite often, because these things are just little lightweight numbers now, they don't have any real information in them. The service provider has to call back to the identity provider in real time to kind of find out what information actually goes with this that they might need to know. And they might get back little lightweight JSON data structures that says who the user is and their email address and stuff like that. And then obviously the application can, whenever it needs to, just use the refresh token to kind of go through that second process automatically. So really that's what the whole token-based models look like. That's how SAML and OAuth work. Now, before I start talking about Windows applications and federation and how you can bring them in, it's actually useful to spend a bit of time talking about Kerberos, which is the Microsoft model. Particularly, looking at it in the way I've just looked at these previous ones, because actually Kerberos is surprisingly similar to that. So you're probably familiar with the model of Kerberos. You've got, the identity provider is the domain controller, and he's got, the user accounts in it. He's also got information for, the servers you might log into, whether it's the PC or a service you're going to call. And the password known both places. Now, normally the model is you're logging into a Windows desktop, and you're immediately doing the Kerberos authentication phase to get a master ticket back. It doesn't actually have to be that way in Kerberos. That's just how it's normally done on Windows. But you get back a ticket, and then an application like, say, Internet Explorer that wants to call, say, SharePoint at the bottom. He calls SharePoint, he gets a challenge to authenticate. So he goes back through the Kerberos machinery in the operating system on the PC, which goes to the domain controller with its master ticket, a bit like the refresh token in OAuth, and comes back with a service ticket for for SharePoint, very similar to the OAuth access token, if you like, except that it can be verified directly by SharePoint. It doesn't have to call back to the domain controller to do it. And kind of the interesting thing is inside that Kerberos ticket is some stuff. Okay, it's all binary structure and it's chock full of information, but some of the information is things like the user name, his user ID, his SIDs, the user SID and the group SIDs, basically information rather like those SAML token claims, if you like. So really the point here is Kerberos is actually an awful lot like SAML and OAuth. It is a token-based model. It's got real claims inside that the domain controller has asserted and issued, which are used for authorization. So what's different? And why is it that people aren't just using Kerberos for this stuff across the internet? There's an irony there, by the way, because Kerberos, when it was first invented at MIT, was an internet authentication protocol. It was meant to be used across insecure networks. So it's sort of ironic that we now view it as having to be confined to the most secure, trusted network. But part of the reason we need to is based on symmetric key cryptography, and what that means is the domain controller is basically a single central root of all trust. He knows all the user passwords, he knows all the service provider passwords, your server machines and services. And kind of the implication of that is, he's like the God servers. He can impersonate anyone at any time of day with impunity because he's the trusted authority for everything. And that's a lot of eggs to put in one basket. It's a rhetorical question. In some respects, you should be very scared that your domain controllers are so powerful. And how do we deal with it? We deal with it by treating them as very sensitive servers, and hopefully in some cases literally having them in sort of locked rooms where not anybody can access them. Trusting that Microsoft has done a really good job of making them hardened servers that will do precisely the job they're supposed to and not be corruptible. But SAML, by contrast, and OAuth and these other models, they've allowed for trust separation. They've got the ability to have identity providers and service providers in different organizations, and they don't have to fully trust each other. You set up a specific sort of bilateral trust by mutual agreement. It's a bit like one-way trust between domains, but people are happier to do this across the internet, whereas with real AD domains, they don't like exposing even one-way trusts if they can help it. And you're not obliged to be like if you're joining a domain, you can't be in another domain as well. You're stuck in one, whereas SAML and OAuth can be anyway, multi-way. And of course, SAML, as we've seen, you can do interesting things. You can actually hide the identity of a user in your organization from the relying party. You can instead just tell them what they need to know. I don't know if you've ever heard of Shibboleth. It's part of the Internet 2. It's one of the Internet 2 projects that was looking at how to do things in university environments where people wanted to do things like anyone taking this particular class this semester, they're allowed to come to access this sort of academic publication, let's say, or people in this research group in that university can access the research results from another group in another university that they work with. And in some of those cases, it's not even helpful to know who the user is at some other university, which of 30,000 students is taking this class. What you really need to know is, are they taking this class? And that complex model in SAML where you can have that middle step that converts some username to some other sort of statement is what lets you do those kinds of things. And you can even chain that process. So if we come back to our quiz briefly, hopefully you can now understand sort of the difference between these three models. My answer to this is that the difference is about the degree of trust. If you give a password to a website, you've given it a credential that can be replayed, and it can be replayed kind of at any system where you happen to have used that password. And we know how people often tend to use passwords in more than one place. So that's like complete trust. You're completely trusting that web app to not abuse your password because you've given them the power to be you anywhere that password works. Kerberos is definitely more constrained. With Kerberos, we're proving who you are to that web application. Kerberos has a delegation mechanism built in. The client can choose to send the web server an extra Kerberos ticket that lets them continue to impersonate that user, to other systems in that domain or that forest infrastructure. But it's like a more controlled delegation step, but it's also stuck in AD. And then with SAML, the web application learns the least possible about you. He's got your identity confirmed if identity is what was wanted, and even that doesn't have to be identity. It can be a claim that's more specific and tailored. So that's really what the difference is. And you can perhaps see why with things like APIs, and web applications, why people are moving towards this model and away from things like Kerberos. So probably a good time to let's come back to the original point of the talk, which is if you've got Windows applications, how are they going to sort of play in this world where people are trying to do identity federation and token-based authentication? So with my chart here again, it's a bit like saying all these applications in that middle band, people have been actively trying. They've been working this in some cases for 10 years with products like, say, SiteMinder to sort of take web applications that were written to do their own authentication and convert them to this, a claims-based model. And that's not trivial. It's been going on for a good many years, but at least it is possible to do that. And sort of the question is almost, okay, Windows applications could be like mobile applications. You could write a new Windows application that used claims-based model. But I suppose the question really is what happens to the Windows applications in that top model? How are they going to play in this model? Because they're based around Kerberos, and people like to keep Kerberos confined inside your corporation and not able to cross boundaries that aren't themselves highly trusted. So really kind of how are you going to retrofit claims? And is there any difference between these apps that makes a difference? So my answer is, well, let's make some assumptions first. If we assume that Windows applications are usually using Kerberos authentication or even entitlement Windows authentication to access resources in a domain environment, whereas most web applications are typically like a web tier over a database tier at the end, they're already working on this sort of claims-based model. When you authenticate to a web application, it's normally, probably talking about my next slide, it normally, you're authenticated at the outside and then your identity is carried through the system. It's just sort of carried around as like a parameter inside the system. That there's no sort of extra validation at every little step you cross because all the steps are just inside, what's considered a trusted system. And mobile apps, they're kind of almost based on top of web apps as web services, same sort of model. There's usually a database behind somewhere. So the problem is Windows applications have a big disadvantage because so many of them are based on using Kerberos, and the trick is how do you go from a token to doing something like Kerberos successfully. Yeah, so I just talked this a little bit, but and really the problem is actually to do with the way Windows authentication works, and that is that to log into Windows, Windows allows two ways of doing that. You either have a password or you have a smart card. Those are the only two direct authentication methods it supports natively. And both of those methods, you end up, if you like, logged into the domain, and you have Kerberos tickets that can carry you anywhere across that whole forest infrastructure and forest trusts even. You've got the ability to do entitlement authentication. It's like a point-to-point challenge response, but you can do that. And that model really sort of doesn't fit very well with claims-based. If I came in with a claim, all I know is the user identity, and I may be prepared to believe that is the right user, but I don't have a Kerberos ticket. I don't have the password hash for doing entitlement. I have no way, by default, of doing anything with that identity other than telling the app, trust me, it's Joe who's logged in. So there are some solutions to this, and there's one's been around for some years, and some newer ones, but none of them is perfect, and they're all have complications in one way or another. So the first way people have been doing this, and I've had these sort of like 5-6 years ago, people were saying things like, we're using SiteMinder to authenticate all of our web applications. Can we put the web interface for XenApp behind SiteMinder? Can WI take the SiteMinder auth token, which is a SAML token, and just launch all my XenApp apps or desktops, whatever it is? And sort of the answer is partially yes, we can, but it's not going to work as nicely as you think it is. and it's probably not actually what you are going to want to do in the end. So people have gone for methods where instead you kind of cheat. You basically say, well, I'll have to put the AD password in a database, in a trusted system, and SiteMinder has the ability to do this. Some other systems do as well. Just so I can use SiteMinder for authentication, I can get the token, and then at the last second I switch to username and password, and I hope I can keep the system where that password is stored, sort of well protected because it's a honeypot of valuable data. Protocol transition, which I'm going to talk about in a bit more detail in a second, is the kind of the way that does it in the right security way, but the way that's also very doesn't achieve what the customer may want to achieve, and why it's quite a problem. And then the final method is actually one that, for a while, I thought was just theoretically possible, although a week or so ago I spoke to a customer who has, in fact, rather unusually implemented that capability themselves. They actually go from an assertion, then they have a trusted system that basically switches to it as if you'd been using SmartCard at that point to do a real Windows logon as if really with SmartCard, which gets you out of the problems because now Kerberos and entitlement and everything can work properly. So out of interest, I think I saw asked earlier, some folks, have you used protocol transition and Kerberos? And has anybody here struggled with trying to do that? Just one person at the back. So I'll talk about how it works first, and hopefully it'll make sense. Because it's sort of a way of doing federation, bringing federation and Kerberos closer together. And it's based on a capability Microsoft added actually some years ago when they did the federation services. They combined that with this Kerberos enhancement. And the Kerberos enhancement is basically a way, but a limited way of doing federation. You can basically, you normally can't get a Kerberos ticket without actually starting the username and password or SmartCard and doing a real authentication with that against the domain controller, except that they created a way to basically declare one server to be trusted, to go to the domain controller and say, with the machine's own Kerberos tickets, proving it's the right machine that's trusted, to say, I want to impersonate Joe. Joe's just arrived with a request. I want to impersonate him. Can you give me a Kerberos ticket? Tickets that I can then use to authenticate other things that expect Kerberos as Joe. And that's exactly what Microsoft implemented. And by the way, it's a matter of interest, the original scenario that pushed them to do this, and which partly explains why it's constrained in the way it is, was actually NATO countries wanting to do sort of war game joint exercises. And it's a bit like the oil and gas. They don't fully trust each other. They didn't want to just have AD domain links between things. They wanted the ability to say, for a joint exercise, we'll create a little domain with resources. We'll put just the things in it that we want for this, and everyone else will do the same. And those little domains will be able to share with each other to a limited extent. And then when the exercise is over, we can just tear it all down. And you couldn't, by design, you couldn't get out of that sort of singularity that they set up especially for the purpose. But that's where the root of where all these complications come from, and this is why people trying to have, say, SiteMinder or true federation and give Windows apps, or even worse, Windows desktops, full desktops to people based on a SAML token or something like that, doesn't work. It's because Microsoft, by design, it was not meant to work, if you like. But the way the model works is something like this. There's this extra special trust. A particular server, like say web interface, might be in front, and it's been marked in the domain as being specially trusted to do things. As for you, by the way, that's just sort of the internal kind of code name for all these Kerberos extensions Microsoft developed. Services for user or something. But the web server is being marked as being trusted to begin impersonating users. And then that's by itself not very useful unless he's going to be able to then authenticate with Kerberos to something else. But he has to explicitly list the other server that he wants to allow authentication to in the domain controller. So when you log in, Joe can come with whatever proof of identity that web server at the front is prepared to trust. It could even be self-declaration. He could just say, I'm Joe. He might come with a SAML token. He might have done a fingerprint authentication. this is where taking some of those complex authentication models, sometimes fits the federation model. And that web server, because he's privileged, he's basically going to talk to the main controller, and he's going to use a special, use a different color for it, token, kind of instead of the real master Kerberos ticket you would get after doing a password authentication or a smart card. He's going to use a special one that he's basically said, I've just seen Joe come up to me, and I want to begin impersonating him. Can you give me a service ticket for this server at the bottom? And he'll get that. And so the browser or the web server or whatever he's going to do is just be using that ticket. And the server in the bottom doesn't know this has happened. He just sees a normal service ticket for Joe with all the sort of useful information like what group he's in as part of it. And you can do multiple hops with this. And the model is basically, there's another way of saying, if you have another server, you can make that middle server trusted to continue doing delegation to other things behind them. This actually turns out to be quite useful in, say, scenarios like using SharePoint or actually using XenApp, where it's got more things behind it that you need to authenticate to, whether it's a database or something. And the model is very similar. He's basically using, it's just rather like the first step. He's asserting to the domain controller, I'm me. You can see that I'm trusted to delegate to this next host that I'm trying to talk to. I don't have a real sort of ticket granting ticket for the user, but please can I have a ticket anyway? And the domain controller can trust, checks his local configuration to see if that's allowed and gives him the right token for doing that final step. So that's the system that Microsoft developed, and this is sort of the main thing we have. We're trying to make Windows applications work with federation environments. And it's used by a number of products. As I think SharePoint 2010, there are people doing this model today. They'll be doing federation. In fact, this is possibly at the heart of how Microsoft may do things like Office 365. They have SharePoint and the cloud service that they're running. SharePoint probably likes to work with domain controllers and Kerberos authenticated backends behind it. But they need to allow identities to come in that aren't in that Active Directory naturally. So SharePoint can do protocol transition. I think I mentioned web interface and XenApp. We added that back in 2005. And interestingly, there's more and more sort of SSL, VPN, and other sort of gateway products coming along now which have this capability as well. So actually, I know customers, for instance, that will that they have a business-to-business federation, and they'll have, say, a Juniper device at the perimeter, which is the only device trusted to take the SAML token from the external party, and will convert it to Kerberos tickets at that point. And they're obviously trying to make things like Windows applications they have published accessible to these third parties, and that is just possible if you like using something like web interface behind the Juniper doing this protocol transition. Yeah, sure. NetScaler, it is being added sort of as we speak. I think by the end of the year, it's supposed to ship, but yeah, we're a little behind on that one. Yeah. Okay, Cloud Gateway is got a different role. Cloud Gateway is actually, when I say Cloud Gateway, because it's multiple components. All of Cloud Gateway covers several of that identity runtime handling stuff I showed at the beginning. We can do authentication from like a receiver or endpoint. We can do the direct authentication to an enterprise as you come in through Access Gateway and hitting Cloud Gateway. We can use that to launch Zen apps on desktop just using the identity, and then the app controller part of Cloud Gateway will then federate out to things like SaaS services like Salesforce or Box or Google and so forth. Or it'll do the password, the older style version of swapping to different credentials for those steps. What it doesn't yet do, and we're looking at adding these use cases in, is that federation in use case. So the moment receiver doesn't know how to authenticate you at one enterprise and take like a SAML token and now come to Cloud Gateway and say, can I come in, can I do things? And the problem there is, well, what is it you want to do? And if what you want to do is get to an application on XenApp, we stand a chance of giving that to you through protocol transition. If what you really wanted was like a full-on desktop that can then run Outlook and browsers connecting to SharePoint and everything else and just have it work, then actually, no, that's still not possible with what we've got today. Any other questions on that? Okay. So I've touched on these already. The problem with constrained delegation is that by design it was made so constrained, and it was constrained to the one domain. So what actually happens, and this is only part of the challenge, what happens is your users can be anywhere in the forest, that's fine, but let's say the web interface server is where protocol transition happens. The domain that web interface itself is in is now the only domain that you can still do these delegated authentications to. So your XenApp servers have to be there, your SharePoint, your Exchange, your file servers, anything else that you wanted to be able to users to touch from those applications without extra authentication prompts or something, they all have to be in that domain. And if you're setting it up for this purpose, that's okay. Federation scenarios where people have an internal application, they need to make it available to someone in a supply chain or something like that. They can probably arrange for that to be true. Where it's a real problem is if it's like a desktop and you just have some complex environment. One of the use cases I've seen is a very large sort of conglomerate in Europe had created an internal entitlement system. They wanted all of their applications internally to be behind this system that I think was Entrust that would do user authentication, entitlement lookups, and then spit out SAML tokens that said who you are and precisely what you're allowed to do. From their point of view, they wanted you to get into a XenApp or Zen desktop as it was, without any change to the applications behind. In other words, they just wanted, whatever domains you were going to touch that needed to work, and that isn't possible. It wasn't possible then, still isn't possible today, at least in the products as they ship. And that's because of that first constraint. You get stuck at the first domain you're in. Even to just do things in that domain, you have to explicitly list every single server, every single service, more specifically on servers that you need to be able to delegate to, which is a complete pain. And the final sort of kick in the teeth, if you like, is you can't do entitlement. And that turns out to be a surprisingly big deal. In theory, lots of applications like Outlook or whatever that do pass-through Windows authentication, they should be able to do Kerberos or entitlement. Indeed, they're quite often, the negotiation says, I can do either, and for various reasons, they might fall back to doing entitlement. You might not have right time synchronization, you might not have DNS or reverse DNS lookup set up correctly. There's all sorts of reasons why Kerberos can actually fail to work, and most of the time you don't even know because it just silently falls back to entitlement and things do work until you hit a use case like this where it can't, and that's where we've started to see those problems. And even worse, if it tries entitlement and fails, it actually it's treated as a bad password attempt, and you can very quickly get accounts locked out. So that's the circumstance we're in, and that's why I today have to advise customers, you have to really want to be doing true federation to want to use protocol transition. This is some of the permission configurations you have to do in Active Directory. These are like the simplest ones just to do, say, a logon to XenApp. And here's like a shortened list of some of the many different services that you in the worst case, you have to find out what applications am I running, what services are those applications trying to use. You may not even know. You may have to resort to things like network traces in Wireshark and start looking to see, was something trying to get a Kerberos ticket for one of these services, I have to go add that service and that, the specific server and service type to that list explicitly. Okay, so that's sort of a summary of where we are in terms of, how identity federation is coming along, why it's becoming more important, how you can use Windows applications to some extent in that world when they were designed actually for the Microsoft domain environment. Slightly separate story if you're designing them new and you can use things like OAuth from day one. I wanted to spend a moment just before taking some questions on where things might go from here, because there is some glimmers of hope. So the conference I went to last week, I went to the same one last year, and a chap from Verizon made a very interesting statement there, which is, most enterprises have no business doing identity management. They shouldn't be issuing people accounts and passwords. They shouldn't be trying to authenticate users because they're not experts in it. Someone like Verizon can do a much better job. They can do risk-based authentication. They can correlate somebody typing a password with the phone they're carrying, with a rental car that they use to drive that city, or on and on. There's lots more they can do. And actually what's happening is there is a move that you probably won't have heard of to create identity federations or identity providers at internet scale. And companies like Verizon are very keen to be in this business. And actually there's a lot of work happening right now to define the standards for how someone like Verizon can be a trusted identity provider for like anyone on the internet or for organizations, and how there can be other people, other organizations like them, so people can choose between them, how they can do it with a high level of assurance, and basically how you as a consumer could come to trust someone like that to authenticate you. If you have a long memory, you may remember about 10 years ago, Microsoft came up with a project called Hailstorm, which is an unfortunate name, where they were sort of offering to do this. And everybody took it at the time as Microsoft wants to authenticate everybody in the internet and be the choke point, and the answer was a resounding no thanks. What's happened since then is people have gone away to figure out how you have to have balances for privacy, how you have to allow pseudonymous and anonymous behavior. You have to put people in control of which identity they're using, when they use it, who they use it with, how often, what information can be sort of deduced as part of that. And that sort of work is going on now, and it's actually building up to the stage. There's a program called NSTIC, that's the National Strategy for Trusted Identities in Cyberspace, which is looking to enable exactly this model for internet authentication, and it'll then be available for enterprise authentication as well. So that's going to be a federation approach. And actually the newest development of all is kind of a recognition, as so many things are moving to this API model, and your folks are reckoning eventually, every person, every device you've got at least is going to have APIs on it. It'll be queryable in some way, and trying to set up the trust model of allowing who's the identity provider, who's the service provider for that many devices is humanly impossible. It has to be done by automation. So again, people are busy working at that model right now. And actually, Microsoft has done some very interesting things with Windows Azure to support that model, and they're doing more stuff now. The last two thoughts I'll leave you with is observation that Microsoft could solve that problem I talked about. They added the constrained delegation, and they chose to make it constrained. They could equally well have chose to make it unconstrained. They could extend Active Directory to do something like, I got the wrong slide here, to take a SAML token directly and issue with a Kerberos ticket if they wanted to. What they have already done in Windows 8, that was kind of interesting, they have enhanced Kerberos delegation in two ways. One is they've made it possible to go across multiple domains. And the second one is they've shifted the configuration burden. Instead of one domain admin having to manage the list, if like the matrix of all the servers that have to talk to all the different other servers and specific services, they've allowed that job to be split up. So each resource owner can basically own their bit of that authorization matrix. But the other thing they've done in Windows 8 is they've added something they call dynamic access control. They've basically made Kerberos even more claims-like. Kerberos has fixed claims at the moment, your user and your groups. They've made it possible to stick in arbitrary other claims, and then to put those claims as in ACLs. So whether in the file system or a database or something like that, you can now have dynamic claims, dynamic access control. And that is incredibly powerful, because if we had the ability to take a token from outside, go through systems that can do authorization, can add extra attributes, control dynamically based on who you are, what device, and if that can then now get into a Kerberos ticket and be checked by an access control list, that's an incredibly powerful environment, which I know some of our customers are very keen to want to have now, but possibly coming. And then the other one is as I say, I hadn't known until a week ago that it's actually possible, but it's even possible now if you want to do a lot of complex engineering to do the equivalent of protocol transition, but in a completely unconstrained way by basically doing things that look like smart cards. So I'm going to have to stop there. We've got time, I think, for maybe 1 or 2 questions if there are any more. If not, thank you very much for listening. Oh, sorry, one.
Have you seen any financial services embrace this?
Yes, I have actually. I'm trying to remember. I've got various use cases. I've seen banks standardizing on it. I've seen various other systems trying to do this rolling out internal applications to like an extended workforce of affiliated partners. These are federation processes. These are people actually wanting to do things like Windows applications they've got running in-house and now making them accessible to someone external. Yeah, it's been happening for some time. It's now starting to see more and more people trying to do this. Okay, so if there's no more questions, thank you very much for listening, and do ask if you want.